And welcome to our tonight's lecture. Before starting by presenting our tonight's speaker, I would like to remind you that our annual workshop will take place this coming Saturday, February the 8th, starting at 9:30 here in the unit and finalizing at 6:30 in the evening. It is my pleasure to welcome our tonight's speaker, Dr. Christian Reepmeye, visiting researcher at the Archaeological Research Unit of the University of Cyprus this spring semester. In 2006, after completing his master's degree at the University of Cologne in Germany and having won a competitive Endeavour International Postgraduate Research Fellowship, Christian moved to Australia to undertake his doctoral research on Pacific archaeology at the School of Archaeology and Anthropology of the Australian National University. In 2013, he was awarded an ARC Discovery Early Career Researcher Fellowship Award with the School of Culture, History and Language and Archaeology and Natural History of the Australian National University to conduct research on the foundations of maritime exchange and interaction in island Southeast Asia. Dr. Reepmeye transferred his ARC award to James Cook University in 2015 and took up a continuing lecture position in archaeology at the College of Art, Society and Education. In 2019, he was promoted to the position of senior lecturer and was named associate investigator on the current ARC Centre of Excellence for Australian Biodiversity and Heritage, focusing on archaeological science applications. His main field of expertise is the study of prehistoric movement, mobility and exchange from the empirical analysis of igneous rocks with geochemical techniques. The geochemical data is combined with exchange and evolutionary ecology theory to understand prehistoric social interaction. Christian research impact has been in the application of scientific techniques to characterize ancient stone tools from Asia and the Pacific, which provide tangible evidence for prehistoric social and economic movements, often over thousands of kilometers of maritime terrain. Dr. Reepmeye has been successful with several project applications, including a series of ARC grants. His latest success was in 2019, in the 2019 round, together with Geoffrey Clark from the ANAU and Frederic Valentin from the CNRS for the project entitled The First Polynesians, Their Origins, Lifeways and Environmental Challenges. Christian has been very active in the field, having coordinated and/or participated in a number of field projects in Africa, Asia, Australia, Europe, and the Pacific. These ventures include past and ongoing research in Sudan, Chad, and Namibia, funded by the German Science Foundation, Vanuatu, Seychelles, Palau, and the Kingdom of Tonga, and Indonesia, funded through multiple ARC discovery grants. Similarly, he has been busy in disseminating the results of his research in international conferences and peer-reviewed papers. He has presented more than 40 research papers and international conferences in many places around the world, and Christian has also organized sessions at big conferences such as the Society of American Archaeology. Dr. Reepmeye has published 36 first-authored and co-authored international journal articles and book chapters. His articles are published in high-ranking international journals such as Nature, Proceedings of the National Academy of Science, Journal of Social Science and Antiquity. He has also served as a reviewer of several articles submitted for evaluation to a number of high-esteemed journals such as the Journal of Archaeological Science, Antiquity, Geoarchaeology and others. In his tonight's public lecture, Christian will talk to us about raw material transport and late Pleistocene, early Holocene maritime interaction in Southeastern Indonesia, East Timor. The floor is yours, Christian. Thank you.
Wow. Thank you, Thanasis. Hearing this is like well, I hope you're not going to have too much expectation here. Anyway, before I start today, I want to acknowledge this is very much a team effort. It's not my own research. I'm part of a really large team, which is culminated in the ARC. ARC is the Australian Research Council Center of Excellence for Biodiversity and Heritage, CABAR. I want to especially acknowledge three people. It's Sue O'Connor from the ANU, Sean Ulm and Michael Bird, and you're going to see a couple of their names popping up in my talk today. As Thanasis said, I'm going to talk to you about raw material interaction networks in island Southeast Asia in the East Timor, Timor-Leste. One of the things is I'm not completely sure how much background you actually know about this area. So there is, when I go through my talk, I have a pretty large part of my talk is background. So I'm just going to introduce what the area is, what the problems are, and why you should care. From a European perspective, Australia and Ireland, Southeast Asia might sound pretty marginal. But one of the interesting things is that the questions we are asking are very similar to what you have here in the Eastern Mediterranean, and the impact we have, or the answers we're finding, the evidence we're finding, can have quite interesting implications for understanding island landscapes, for example, or early colonization of islands, also in the Eastern Mediterranean. So the talk is divided in 3 parts. So the first part is I'm going to go a little bit of a biogeographic background about island Southeast Asia, about the land masses of Sunda and Sahul, which you might not heard about, the area of Wallacea, what that all means. Then I'm going to talk a little bit about the colonization of Sahul, which is a really important part to understand the maritime capacity of Pleistocene people. And that is something you might find really interesting here. And I try to convince you that the evidence shows that there is substantial maritime capacity available for Pleistocene populations. Then I'm going to jump forward in time and discuss the dominant model. What we understand, or what we assumed before, was how social interaction in island Southeast Asia started, and that is very much connected to the idea of a Neolithic revolution, which might sound quite familiar to you here in the Eastern Mediterranean when you're thinking about when maritime interaction starts. The dominant idea about when social interaction starts in island Southeast Asia is the same. It's associated with the Neolithic revolution, or migration of first farmers, associated with the so-called Austronesian Expansion. And then once I've covered that, and I hope that's going to take about 25 minutes, then I'm going to come back and jump back in time a little bit and say that why the dominant model is wrong. And I'm going to tell you a little bit about my research, which I'm doing at the moment with Sue O'Connor, especially in the South Sunda Island, Eastern Indonesia, showing that there's raw material transportation starting at the terminal Pleistocene, early Holocene boundaries. And then at the end, I'm going to do a little bit of understanding of why I think this kind of happening. We're talking about environmental correlations, maybe risk management, and so on, adaptation to unpredictable resources. Okay, so it's a bit of a tour de force, and I hope you're going to stick with me when I run through the themes. All right, so should turn it on. Yep. All right. So the research area which I come back to at the moment is the southern island Southeast Asia. So you have here the large landmass of Borneo. Up here you have the Philippines, you have Java, you have New Guinea, and you have the north coast of Australia. And my research area is this little square here, which is the South Sunda Islands, and I specifically look at Obsidian artifacts from a few sites here in this area on the eastern coast of East Timor, Alor, Weta, Atauro, and then an island of Kisa. I'm going to introduce 2 sites later in the talk, the site of Tronbonlé on Alor and the site of Herisot and Taper on Kisa. But that is in the later phases of my talk. So at the moment, just think about this is the area which we are covering today. It's island Southeast Asia. So my research framework, and I already explained it a little bit, is when do we think maritime interaction starts in island Southeast Asia? And there's these 2 big ideas, which I already covered, is whether does it all start only with the Neolithic movement of migratory first farmers, or do we have long interaction networks, maybe going back into the terminal Pleistocene or even further. The second one, which is also really interesting, also might be quite interesting for you here in Eastern Mediterranean, is the question whether, because we have an island landscape, this whole area is an island landscape, are all the islands colonized at the same time, or do we see sort of stepping stone islands, or is the landmass, larger islands, maybe being colonized a little bit earlier, smaller islands being colonized a little bit later? What does that mean? Is that actually true, and so on? So we're going to have a look at that a little bit too. So let's start with a little bit of biogeography. I'm not sure whether any of you have heard the term Wallacea before. Wallacea is the island area here between Borneo and New Guinea. And what is really important in this area is actually the blue shaded area, which is the continental landmass of Sunda and the continental landmass of Sahul. These continental landmasses were at lower sea level, were connected, were not connected with each other. So Sahul is a continental landmass encompassing New Guinea, the Australian landmass, and Tasmania. And you can Sunda is all the area of Borneo, Java, Sumatra, and so on, going all the way up to the mainland Southeast Asia, being connected to a landmass. The interesting thing about the Wallacea is that this is an island landscape which was never connected to the mainland, neither to Sahul nor to Sunda. And that derives from the tectonics of the plate movements. So you might know that Australia 130 million years ago was connected to Antarctica, and when it was Gondwanaland, and it was, since then it's moving northwards. It's actually crashing into the Australian or Eurasian plate. So these boundaries are contracting. So it's not that these are divergent, they are actually contracting. One of the really important things about this, the Wallace line, is that it's a real biogeographic boundary. Terrestrial fauna in Sunda and Sahul look completely different. They are not at all similar. I put a couple of nice pictures up here. So we have mammalian fauna here on Sunda. You have pandas, and you have tigers, rhinoceros, and elephants, and so on. And then you have the marsupial fauna of Australia, which are kangaroos. You see a Tasmanian devil, and a couple of smaller animals. So these are completely divergent mammalian families. And it indicates that there was no contact between these two land masses for a very long time. The other thing what is really important is, so the mammalian terrestrial fauna is completely separate. From a geological perspective, being converging tectonic plates, they are really geologically active. And for me, as a geochemist who's interested in obsidian, there's a lot of volcanism happening. So we are on the boundaries of what we call the Pacific Ring of Fire. You can see here the dark patches are all the grabens and the island arcs, and you have a lot of volcanism happening there. Volcanism is something which I find really interesting because it produces igneous rocks, which you can source. And that's what is my expertise for a long time, has been for quite a while. So you have here, you have what is really happening here is that the oceanic plate is subducted under these two continental plates, and you have a lot of volcanism. All right, why do we care as archaeologists about that? Well, one of the important things here is that when people colonized Sahul, they had to cross Wallacea. They had to cross Wallacea, which means they needed some sort of maritime watercraft to be able to colonize Sahul. There has been lots of different ideas about what kind of colonization movement happened, and new research, or research which we are doing right now, is arguing that this colonization was deliberate. There's a lot of discussions about whether it was an accidental movement, that there were drift voyages happening, people were swept off the shore. There's always this interesting debate about this pregnant woman being swept off the shore in Java, swept on the coast of northern Australia, and is the eve of all of us, of indigenous people in Australia. So these are actual arguments which has been argued in the past, and they are still very much sort of discussed. So accidental or deliberate colonization is still a discussion which is really ongoing. One of the big problems with proving deliberate colonization is that we have no evidence of watercrafts. You're familiar probably in the Eastern Mediterranean here too, is that watercrafts, the first watercrafts are actually really late. So when do we have them here? So early Mesolithic, Netherlands, what, 10,000 years ago, we have the first dugout canoe. And that is the same problem we have in island Southeast Asia. We don't have any evidence for watercraft. So what we're using is proxies. So we have to look at what kind of proxies can we use to identify whether there was maritime movement of people, whether there's capabilities of people there. I put a couple of images here up of ethnohistorical available data of what kind of coastal watercrafts indigenous people in Australia used. And you can see they are fairly simple bar canoes. You have a couple of rafts here. You have now and then you have a small dugout canoe. These exist later on, but one of the really important watercraft or really important technologies there, they are all coastal. They are not offshore islands. And if you look at Valacere itself, is that island landscape is, there are substantial sea gaps separating islands from each other. Sometimes they're only 30 kilometers, but there is a couple of really large sea gaps, up to 90 or 100 kilometers, which people had to cross to reach Sahul. For these kind of sea crossings, you needed some substantial watercraft being available to you. One of the really important parts when you're thinking about biogeographic understanding proxies for watercrafts is inter-island visibility. And I put just two examples here up for images from island Southeast Asia and from Cairns, where I live, to show that there's this fundamental cognitive, there's an idea that there's a fundamental cognitive difference between if you see in the distance islands or if you don't. So here you have island intervisibility. So when you're taking off with whatever raft you have or whatever watercraft you have an aim. You can say, oh, well, I'm going to reach that eventually. Here you don't know. And that is something which is really important for island Southeast Asia or Valacere, is that because there are a couple of sea gaps where you don't have inter-island visibility. Okay. So this is the work of one of our PhD students, Shimona Keeley, who had a look at exactly that problem. So she looked at inter-island visibility, and you see here two different shaded islands or areas. This is the coastlines of 65,000 years ago, so that is about 80 meters lower than it is today. You see a dark shaded area, and you see a lighter shaded area. There's absolute intervisibility and relative intervisibility. Absolute intervisibility means you stand on the shore and you see an island on the other side. Relative intervisibility means you're paddling out from the shore, and the moment you don't see your coast anymore where you left, can you see another coast? So that's the difference. And one of the interesting things is that if you look at the northern part of island Southeast Asia, the islands are pretty intervisible. There are a lot of stepping stones. So it's not just one sea gap which you have to cross to reach the landmass of Sahul, but it's pretty much, you can see all the islands. On the southern path here, there we have this really large sea gap between East Timor and the North Australia, and that is a substantial problem. So we had a little bit closer look at exactly this problem, because inter-island visibility, we could say, oh, well, these islands are all intervisible. It shows that we don't really need a lot of high-tech watercraft available to actually cross this. So maybe drift voyaging works. So what we were doing in the last year, this came out last year in Science Reports, was that we had a bit of closer look taking oceanographic information into account. So we have this idea of inter-island visibility, but how does it actually work practically? So if you are being washed off the shore, you do see an island on the other side, would you actually be able to easily cross these sea gaps, which are sometimes not very far? It's like Bali and Lombok, for example, down here, which is one of the really nice biogeographic boundaries, is only 13 kilometers apart. It's a very short distance. So we had a look at 17 sea crossings, and you see here numbers. The numbers are categorize from 0 to 4. 4 means you stand on the coast and you see another island. 0 means you can't see the other shore from anywhere on the island. There are other options. For example, if you step on a high mountain, and you see I've on the other side a really high mountain, so you would see the other shore. So there's different. We had a little bit look, taking a couple of other things into account, just to identify whether this is actually very easy to cross this island landscape. And yes, we still have that the northern route is a really, probably we have a lot of inter-island visibility. However, we have a couple of places here where even when you're crossing, say from Sulawesi into Ambon, that you still haven't reached the other side. And then you have these sea gaps happening where you don't have inter-island visibility. So it's not just one stepping stone, there's actually multiple ones. So if we are modeling this, and this is, I'm not going to bore you with the algorithm, but this is what we call accumulated probabilities. So what we are calculating here is how likely is the chance that the random wash off people from the shore be able to reach the other side of the coast. Can that randomly happen or not? So the blue is the random, and the redder it gets, the higher the chance is of people being able to cross onto the other shore. What we identified was that there's actually a very, very low chance of people being able to cross all the different sea gaps from Sundas to Sahol by drift voyaging alone. The chance was less than 1%, which is good because from our perspective, that identifies that these people who are taking off from the shore needed some sort of watercraft, and they need not only watercraft, they need also propelling. So they needed some sort of paddle or so on. If you are assuming that people can move across the sea gap in a certain direction, say they are moving at a speed of 0.2 knots, which is actually not that fast, so you can do that with just a simple paddle. The likelihood of people crossing these sea gaps is up to 80%. So it's a very high chance of people being able to cross these sea gaps. One of the really important things is there is a lot of really strong currents in island Southeast Asia. So a lot what happens in this model is people being washed off the shore, and they're actually not washed off on the opposite side of the coast, but they're actually washed alongside the coast or being washed back onto the beach. So that's what's happening a lot. So one of the ideas in terms of our modeling, or one of the results of our modeling, was that the likelihood of random movement of people being washed onto Sahul is very, very unlikely. And interestingly, the genetic data supports this. So this is a work being done by Alan Cooper's group from Adelaide. He looked at the genetic genetic setup of indigenous population, modern indigenous population in Australia, and he identified that there are at least 4 different haplotypes living in islands in Australia. And these haplotypes are old. So they split apart before people were crossing into Sahul, which just means you have significant populations moving over into Australia. They avoided the idea of northern or southern route, which is okay. They are geneticists, they don't really have to worry about that too much. The lines here is then looking at how Australia, or how we think Australia was colonized. I'm not going to go into that much detail more. The only thing what is really important is that there is at least 4 different groups moving into Australia, and each of these groups needed to have a significant amount of people because you need a minimum number of people in each clade to actually be survivable. It's not just one pregnant woman being washed onto the shore. For us as archaeologists, there's a little bit of a problem because the northern route is the easier one than the southern route, because you have this sea gap between East Timor and North Australia. However, the dates in North Australia are older here than they are up there. So from an archaeological perspective, we still have a lot of work to do to identify which specific route people have taken. This is also represented in the archaeological record. And this is one example of a rock shelter. It's the rock shelter of Jermalai, which is up here. It has been renamed to Asiaukuru. You might have seen that this has been published by Sue O'Connor back in 2011, looking at pelagic fishing, so deep sea fishing. And she identified at this site, the original or the oldest site dates to about 42 to 44,000 years ago. She sees pelagic fishing appearing straight away with the earliest sites. So people were able to move offshore to fish and to use these maritime resources. These are not inshore fisheries, which you can, for example, catch off the reef at low tides. So these are deep sea fishing. So people needed some sort of watercraft on a regular basis to go out. She also had some of the oldest fish hooks there, but they date a little bit later. My involvement with the site was that we also had obsidian being used there, and it appears to be, and it fits into what I'm later going to talk about, that this is that the initial obsidian transportation happens at about 15,000 years ago. All right, so I hope I convinced you that there's most likely quite a substantial movement of people into from island Southeast Asia into Sahul. And I'm gonna move on now because I'm already waffling too much. Okay, so what is the classical model before? When we are thinking, well, people were not really in the Pleistocene maritime adapted. So idea is what is called the Austronesian Expansion. So Austronesian is a language group. It's a bit similar like the Indo-European language group or language family. And for a long time, it has been assumed that this is the primary driver for any kind of Neolithic innovation in island Southeast Asia, as well as in the Western Pacific. The dates for the appearance of Neolithic innovations support this idea. So we have dates here in Taiwan, around 5,000 BP, and we have dates here in Tonga and Samoa, where we think the migration of these Austronesian people ends in the first time is about 3,000 years ago. So there is a chronological discrepancy between the two that supports the idea of a movement of people from Taiwan into the Western Pacific. Just a map of what we think, what we identified as the Austronesian language family. It's quite a widespread language family. You see oceanic languages pretty much covering the whole of the Pacific. And we have Western Malayo-Polynesian language groups, which also assumes to colonize Madagascar about 1,500 to 2,000 years ago. So it's a widespread colonization or movement of people. The genetics, again, I've been involved with that a little bit. One of our sites has been used to identify the genetics of this movement. It appears that it supports this idea of a migration of people. So I just want to have you have a look at the blue here. So the blue is an island Southeast Asian signal. The green is a Papua New Guinea signal, and it identifies that the earliest populations in the Western Pacific are Asians rather than Papuans. So Papuans means the area here of New Guinea, and also actually including parts of Northern Australia, which is the idea was always like, where does the original population who colonize Western Pacific derives from, whether they are Asians or whether they are Papuans. So genetic data indicates that there might have been Asians. So they are that supports the idea that there's a migration of farming people from island Southeast Asia into the Pacific. The representation of this is what we call Lapita. I'm not sure if you heard about the term Lapita before. Lapita is defined as a certain ceramic decorations, and you see these beautiful pots here being found all over in the earliest sites in the Western Pacific. These are carinated vessels, quite large vessels, beautiful horizontal lines of dentite stamping and sometimes lime infill, red slip pottery. I have a couple more pictures of it because it's just so beautiful. So these are the carinated vessels. You have face motifs and so on, and they are very similar in the Western Pacific. The idea of a colonization movement of migratory people also in island Southeast Asia derives from the idea that this is a migration of people into the Western Pacific, and that's why I'm telling you this about this. My research looked at obsidian, and we can see a clear directionality of the people moving. So I sourced obsidian artifacts from Vanuatu in my PhD, and I was able to identify that these came all from an obsidian source here in West New Britain. This is a really interesting pattern where we can see that people were moving this obsidian eastwards into which is here the green shaded areas with them in the earliest colonization movement, but then they abandoned this kind of obsidian very quickly. So they are not maintaining these interaction networks. This is very much associated with an earliest colonization. Big problem with our ideas of this obsidian is that we don't really know what they've been used for. Like, why is it so important to people moving this raw material over 2,500 kilometers? We have very, very limited amount of formal tools. Most of them are just simple flakes. We have hardly any use wear on them, so we don't really know what they were used to. We have a couple of artifacts which we call gravers, which have this really interesting alternating retouch where you have this lip being retouched, which we might assume that is associated with tattooing. So there might have been tattooing implements, and if you know a little bit about the Pacific, tattooing is quite an important visual part of the cultural landscape of these islands. If you look at, this is a map of a cemetery site. The black dots here are obsidian, the white dots are graves. Interestingly, the distribution of these obsidian tools is not associated with the graves, so it has, again, is a little bit of a problem of why people are moving this if it's not associated with grave goods or so on. So we don't really know why people were moving this this material. So what do we have? We have the linguistic data shows that we have a directional movement of people from island Southeast Asia into the Western Pacific. We know that genetic data shows the same thing, that we have a movement, a migration of people from island Southeast Asia into the Pacific. We see ceramic appearing. The archaeological record shows that there is a migration of people, and we see a directionality of this movement. However, the problem is that we have a really hard time linking Western Pacific colonization with island Southeast Asia. So the archaeological record looks completely different. So yes, we do have red slip pottery, but the pottery looks not really like what we see in La Pita, so the pottery is different. We don't see any obsidian moving from island Southeast Asia into West New Britain or into Papua New Guinea, which is the starting point for the Western. So we don't really have a very good argument connecting these two landscapes archaeologically with each other. The other problem is when we are thinking that this is a Neolithic communities, these are Neolithic groups depending on agriculture. One of the big problems is that they are completely changing their mode of production, starting from island Southeast Asia into the Western Pacific. So when we are thinking that they're starting out with Taiwan, all in northern island Southeast Asia is rice and millet. All the agricultural crops in the equatorial area of island Southeast Asia and the Western Pacific are tuber crops. So this migratory population completely abandoned the basis of their agricultural productivity and changed it to a completely new resource. That is a bit of a problem archaeologically to argue this, to link these two populations with each other. There's an alternative model who looks at the idea of long-term interactions in island Southeast Asia as the driver of this Neolithic innovation spread. And maybe that the genetic data is really not that representative because at the moment we only have a few individuals being identified. So there's a lot of work still to be done. This idea, this alternative model, is the basis of my argument that there's actually longer-term interaction networks in island Southeast Asia happening, and it's not all associated with the migration of people from the north into Western Pacific. All right, this is a lot of information, I'm sorry. But this is, okay, I think I'm sticking quite good to the time. All right, so just as a little summary, so the dominant model of what we think social interaction networks in island Southeast Asia and Western Pacific appears is associated with the migration of people. There's a little admixture of these populations with already established populations in in Papua New Guinea, represented by the genetics. So this is all blue, no green. However, this model is based predominantly on linguistic and genetic data. The archaeology is much more difficult. And we do have alternative models which suggest that there might have been a much older interaction network happening. Okay, just a reminder, the research framework, I'm not going to read this out. So how did I get involved with all of this? Well, I already said that I did my PhD on these colonization movement of people into the Western Pacific. But we also started to have a look at island Southeast Asia, specifically from this idea of obsidian movement. What can we tell? Because obsidian was so successful in identifying directionality of movement of people, connectivity with islands in Western Pacific. So we should have something similar in island Southeast Asia too. And this island, like I said, this island group is a very tectonic active area. There's a lot of volcanism, so there should be a lot of obsidian around. And it's true, there is a lot of obsidian around. So this is a review paper which I published in 2011, looking at obsidian artifacts and obsidian sources in island Southeast Asia. I was using ICP-MS to analyze these obsidians to actually have a bit of higher resolution data set. But what I identified there is, yes, we do have quite a fair bit of obsidian, and we do know quite a few obsidian sources in island Southeast Asia. However, from the assemblages which I looked at, I was only able to successfully source 40%. There's 60% of the artifacts being utilized in sites in island Southeast Asia which have no source. And that's a bit of a problem for us. The other thing which was really interesting is what we identified at that stage, and this is work I did with my Filipino colleagues, Lee Neri and Alfred Pavlik. We were looking at two sites in the central Philippines, which is the Bubong Rook Shelter and Ila Cave on Palawan. And we identified obsidian tools there. We were able to match these obsidian tools to a jointly source, but we were not able to identify where the source came from. The interesting part is not that we were able to match this source, but it was the age of it. So the age was about 11 to 12,000 years ago, which is a lot older than the previous idea of when does people start to interact with each other across islands, which is around 4,500, 4,000 associated with the migration of people and the Austronesian Expansion. So that was interesting. So that was the first identification of obsidian movement dating back to the sort of terminal Pleistocene. Then, based on that, I got involved with Sue O'Connor's research at the ANU, who looked at the whole idea about, she wanted to re-identify early maritime or coastal adaptation of people on islands. She wanted to look at colonization and so on. And I was invited on the project to look at the obsidian as a geochemical expert. So and this is where I come back to my research area. Okay, so we had a look. So I'm going to present now two sites, the site of Trombolé on Alor and the site of Kisa, of Hersotete and Tape on Kisa, to show like how do the sites actually look like? What are the sites which we are working on? So the first site is Trombolé. And as you can see, this is a coastal site. It's about 150 meters away from the coast. It's in an escarpment. So this is not coral. This is not uplifted coral limestone. This is actually volcanic rock. There are deep fissures in the island, in these escarpments, in these formations, which creates these really nice overhangs. And that's a really common site type in Australia as well, and island Southeast Asia. We call these rock shelter sites, and they are quite common. Normally, they are targeted by archaeologists because they have better preservation than a lot of other like open areas and so on. So we don't really have that many really deep caves. So we try to target these kind of rock shelter sites because from our experience, we have deeper stratigraphies there. So Suoconna excavated 3 1 by 1 meter squares. So it might sound small for you guys, but that is it's a little bit of a different way to do archaeology. We don't really usually do these large-scale excavations there. We do small-scale to actually understand the chronology of the sites and the cultural sequence. So 3 artifacts were excavated, 3 square meters were excavated on this site under the drip line. And we found quite a nice stratigraphy. So this is an example of 1 square meter, which is the site B. And you can see this is a really nice cultural sequence of 13 layers. Sue was able to date she got quite a lot of radiocarbon dates. It's probably about 30 radiocarbon dates being taken out of this. So we have a pretty good understanding of the absolute chronology of that site. What is really interesting is that we don't have a lot of inversion, which is really important if you're looking at radiocarbon dates. Inversion always indicates disturbances in sites. We don't have any inversions, so that means that site, the preservation is pretty good. What we could identify is, so we have this sequence of 13 layers, is that the base layer is around 20,000 years ago. So we have an occupation of 20 to 12,000 of 18,000 years ago. Then we might have a hiatus here, and we have a sequence of about 15 dates, which dates to the sort of terminal Pleistocene, mid Holocene area, so 12,000 to 7,000 years ago, and then we have a late Holocene occupation up in the top, where we also see a ceramic appearance on the site. So this is how one of the sites look like. It's a pretty good stratigraphy. We don't have inversions. We are pretty confident that there's that we have a good idea about how the chronology looks like. The other site is Kisa, on Kisa, which is nicely in a limestone environment, which means we have a bit of better preservation. And there we excavated about 2 square meters and had a look at. And one of the ideas there was to look at, does these sites on small islands look different to larger islands? So Alor is quite a big island. It's about 150 to 200 kilometers across, 30 meters wide. So it's almost the size of Cyprus. Kisa is a lot smaller. So Kisa is only 10 kilometers across. It's a very depauperate environment, hardly any surface freshwater available. What is important at both of these sites, or the sites of Kisa, is that there's no volcanic rocks exposed on the site. So this is all limestone. The stratigraphy on Kisa looks very similar. It's a little bit more complicated than on Alor, but we identified 9 units. The dates are still pretty good. There's not a lot of inversions. There's a couple up here in the top part, but in general, we assume that the stratigraphy is pretty good. The basal date is 15,000 years ago, so it's a bit younger than Alor. And we do have quite an hiatus between 9,000 and 4,000 years ago. So it seems to be that there's an abandonment of that site around 9,000 years ago, which might be important to understand what's happening in terms of the colonization of these small islands. All right, I looked at the obsidians, and this is a sort of accumulate data from Alor. Alor was nice because we had actually a substantial obsidian assemblage, more than 1,000 pieces. And I was analyzed that with PXRF, which was just easier and quicker. And what we identified, and this is the only diagram I'm going to show you, and the only table, so that we have 3 groups here. So we have a green, a blue, and a red group, and there's actually a couple of other pieces here which spread a little bit further. We named them creatively group 1, 2, and 3, and group 3 here you can see that there's a little bit of a spread, so we were not 100% sure whether this is one source or whether this is multiple sources. What we thought there was that the group 2 and group 3 sources are local obsidian sources on Alor. We didn't know that at that stage, but we assumed based on the distribution, and I'm going to show you that in a minute. And then we have group 1. And group 1 is a really interesting source because when you look at that in the region, I'm going to come to it in a minute, again, is that source being used in multiple sites throughout the area. We don't have a source for this at the moment, and this is part of sort of ongoing research, and I've just put a couple of applications in to actually go back to the island of Wetar to have a look whether there is an obsidian source there. But what we assumed here is that Alor is, or the group 1 is not local to Alor. We had a look 2 years ago to find this obsidian source on Alor, and we were successful. So we found this group 3 obsidian, which we assumed to be local. And indeed, it is an obsidian source which is local to Alor. It's only 30 kilometers away from the site. It's in an andesitic flow. There are little, you can see little obsidian clasts, and it's a pyroclastic flow. It's a very classic obsidian source. What we identified is that all of these, what we thought 3 subsources, were actually only one source. So this one locality, it's not multiple localities, and we are quite happy with that. So that means that this group 3 obsidian indeed is local. So that's important. So why is this? Why is this important? Because if you look at the chronological distribution of the obsidian sources throughout the sequence, you see that red was group 3, green was group 2, and blue was group 1. Is that group 2 or group 3, which is the local source, is the one which is being first used. Interestingly, it is being used throughout the sequence, all the way up to the mid-Holocene. But we do see a starting of movement of other obsidian sources being used at the sites too. And we were really excited about that because we could show that there's a start of an raw material transportation to the sites, because we assume that this group 1 obsidian is non-local. And I will try to convince you in a moment that you agree with me that this is non-local. Yes, okay. The site of Kisa, the obsidian looks a little bit different. So we don't have as much obsidian. It's about 100 pieces. But it seems to be that that people on Kisa only used predominantly one obsidian source, not 3. They might have used a little bit of this group 2 obsidian, but predominantly they were only using one source. And that is actually very similar to a lot of the sites in the eastern part of the region. What is also really interesting at Kisa is that the obsidian distribution is associated only with the lower parts. So as I explained in the stratigraphy, we have a hiatus at Kisa, which is the earliest part is dated from 15,000 to 9,000 hiatus, and then late Holocene occupation. There's no obsidian associated with the late Holocene occupation. So that's quite interesting. So there might be something happening there, that this island has been abandoned and then reoccupied later on, but when it's reoccupied, people not using the same raw materials anymore. So that's interesting. So this is a little bit of a summary of all the sites which I had a look at in the area. So you see there's quite a few sites on East Timor now. This is Kisa again in Herisoteat and Tapa site. You have Atauro, there's one site, and here was Tronbonlei, and the other side is Macpan, which I haven't talked about yet. But if you look at the distribution of obsidian, how obsidian is being used, you see that blue, which is group 1, is predominantly used in the eastern side, and group 1 and 2 is predominantly used in the western side. Red, which is group 3, doesn't occur anywhere else than on Alor. So we don't have any transportation of that raw material outside of Alor. Which is interesting because on Tronbonlei, that obsidian source is being used throughout the sequence, but it's not been transported off island. So it seems to be we have quite an interesting social interaction networks happening there, which seems to overlap because we do have transportation of group 1 obsidian to the west. We have no group 3 obsidian moving to the east, but we do have one piece of group 2 obsidian all the way in the east. So it is quite an interesting pattern. And we haven't really figured out, to be honest, what this all means. However, so why does it happen? So, and that's just really speculative to understand island colonization. So why does this happen? So one of the interesting ideas which came up was that it seems to be that the initial movement of obsidian is dated around 15,000 years ago. So it's not associated with the earliest colonization of the islands, because these islands been colonized 40, 50, maybe 60,000 years ago. So there's people were living on this island permanently, at least on the larger islands, and around 15,000 years, maybe 14,000 years ago, people are starting to move these raw materials between the islands. So what is the environmental correlation there? The environmental correlation is that at that time period, in the sea level curve, you have this really steep rise of sea level. So as you know, from the transition from the last glacial maximum up to the Holocene, we have a very steep sea level increase, but it's not linear. So we have plateaus, we have the younger dryers where it drops again, and so on, all of these things happening. The interesting correlation is that the start of this obsidian interaction network is correlated with what we call meltwater plus 1A, which is a time period of about 14,500 to 14,000 years ago, where the sea level rose from -19 to -50 meters. So it's a really fast rise of the sea level. So this is, you can see this here. This is this. So you have a plateau here, and about 15,000 years ago, bam, it goes really quickly up. Interestingly, you would now assume, oh, wow, this is a catastrophic thing for these people in coastal environments. Everything is going to be inundated. The interesting thing is that sea level rise is not necessarily associated with a decrease in productivity of coastal environments, at least not in island Southeast Asia. One of the important things is that in island Southeast Asia, a lot of these islands don't really have very precipitous shorelines. They are really steep. So because they are uplifted limestone islands or uplifted volcanic islands with a fringing reef. And sea level rise actually increases productivity of these coastal environments. So we do see that people, maybe that was a push factor, that people are engaging more with the coastal areas because the food resources are completely abandoned. Abundant food resources appearing there. So that could be a really interesting pull factor. An interesting push factor is if you look at the terrestrial environments on these islands, is during the last glacial maximum, a lot of these tropical islands were actually open woodlands. So we call that open savanna environments. So it was drier, like it was in islands on the tropics, it's not, the last glacial maximum is not necessarily colder. The dominant thing, it is drier. So which means you don't really have tropical rainforests at that time period. So people were living in open savanna open savanna woodlands. You have climate amelioration, which means it get wetter and warmer, and what appears like dense rainforest environments. And although we know that people, modern hominins were adapted to rainforest environments, well, living on these islands, even people today try to avoid moving inland because these jungles are quite inhospitable. They're really hard to traverse. So maybe where people were pushed out of these environments onto the coasts. And even if you're thinking about how communication networks work on islands, a lot is associated with coastlines. So people tend to communicate along coastlines easier than into the inland. And that might be associated as another environmental factor which might push people onto coastlines. All right, I'm almost done. One of the interesting things about colonization of small islands, especially in Kisar, is that we do see this pattern which is similar to what we see in an Eastern Mediterranean, that small islands are colonized later. And that might be associated with these small islands having less terrestrial resources. It's harder to survive on these islands. There might have been unsuccessful colonization movements, which is probably something really common. So people moving onto the island, stay there for a few years, and then actually abandon it again. So that is, and it's really hard to detect that in the archaeological record, whether we see a permanent settlement on the sites, but we do see these long stretches of abandonment happening on these small islands. And so that's really something that's really interesting. Social interaction networks represented by Obsidian might be a risk minimization strategy where people are engaging with communities like founding communities on large islands, because this is quite a risky adventure, moving to these small islands. So that might indicate that people were still in contact and stronger contact with these founding populations. So we have a social factor involved in that. And the last thing is, well, maybe at that stage we already start seeing a community of culture, similar to what we see, what we assume what happens in the Neolithic. We do see Obsidian as only one representation of these interaction networks. There are actually other representations in the archaeological record. This is just an example of Nautilus shell beads, which are very similar throughout the area. So this might actually show that we see a starting community of culture earlier than the earliest than the Neolithic spread. All right, to summary, just a few conclusions to my research. I hope it didn't bore you too much. So what I see in Island Southeast Asia, at least with my Obsidian research, is that we do have a starting interaction networks around 15, maybe 14,000 years ago, a lot earlier than the dominant model of the Austronesian Expansion. These maritime interaction networks might have been triggered by environmental patterns, environmental changes, making resource accessibility more unpredictable. People need more social interaction to mitigate risk. And the last thing is, and that is really something which is connects it again to this idea of an Austronesian expansion, where I don't really have made my mind up really whether that is true or not. And at least on Kisar, these Obsidian networks are only associated with phase 1, which is the terminal Pleistocene, early Holocene occupation. When the Neolithic occupation comes in, there is something different happening. So Obsidian is not important anymore. These interaction networks might be completely different, and that might show that there is something different happening when the Neolithic arrives in Island Southeast Asia. And that's it. A tour de force through the prehistory of Island Southeast Asia.
For the lecture. Congratulations. particular in the Aegean basin. So I think that most of us, we could follow the problematic, etc. What I wanted to ask you is if during detecting all these networks, exchange networks, if you have considered parameters of seafaring like streams and winds.
Yes, so that's like the modeling we did for the earliest colonization. I didn't do that for the terminal Pleistocene, but if you have a look, oops, oh sorry, I turned it off. A second. I want to get out of this. If you look at the modeling which we did, one of the interesting things in that area is actually that the movement of people throughout that area might not be particularly difficult. So have a look. One more. There you go. So the area I'm working on is this area here. And when you remember when I was saying when we modeled colonization movements, the red is the parts where we think that the movement of people between islands is easier, and the blue is the one where it's the difficult part. When you take oceanographic monsoonal wind patterns and so on into account, that area is probably quite beneficial for the movement of people between islands. So it might indicate that people were easily moving these really short distances. So one of the interesting things is that when you look at ocean currents, the really strong ocean currents, which is the Indonesian through flow, they are actually going through here and through here. So these are the major currents there, which would be perpendicular to the movement north-south, so they're east-west. But my area most likely is an area where maritime movement would have been fairly easy. Does that answer your question?
Yes, yes.
Yeah, okay.
If I may,
Yep, sure.
Is there a moving only of the raw materials, or at some specific period of time are you seeing that the import of specific kind of obsidian was associated with the importation of technology?
That's a good question. Well, like one of the problems, there is this assumption that technological interaction happens during that time period. It's called the Hoabinyan, which it's like one of these technological cultures. Is an idea about reduction sequences of stone artifacts, which are similar in these areas. As a geochemist, I always have a problem with identifying technological similarities with a movement or interaction between people. So I would like to have hard scientific data, and that's why I'm looking at the sourcing of the material. When you look at the sides, obsidian is really just a small amount of the total assemblage. Like, we have a lot of material being used there, but it's predominantly, well, we haven't really had a close look at it, but it is basalts and cherts and so on. So there are other raw materials being used. And the next stage would probably be to have a look at these other raw materials. The other thing, what is happening, and this is where I'm thinking about this community of culture, is that we do see similarities in the shell artifacts. So, and that's shell is one of these, in tropical environments, is a really good alternative resource to stone. People were using a lot of shell for just simple raw materials, so to make actually flakes, can make flakes from shells. You have shell ornaments, like these beads, which appear to be similar throughout the islands. And that is something which where we are sort of arguing that this is not only the movement of obsidian, but it might actually be other things which have been moved. The other thing which is really interesting is the translocation of animals. So we don't really see this here, but if you go further to the east into West New Britain, there is an interesting case that people introduced couscous onto an island, and that completely changed the fauna, and it changed actually behavior of people, of hunting behavior of people too. So the island of New Ireland in West New Britain is an endemic fauna which is predominant by bats. And if you look at the earliest colonization and the earliest levels of in sites, hunters are targeting these bats predominantly. They are very strongly focused in certain areas. They need caves, so these sites are associated with the location of these animals. Then at around 20,000 years ago, couscous is going to be introduced, which is not native to that island. And couscous is not an animal which lives in caves, so it lives in open woodland. And at that stage, you see a complete change of hunting strategies. So people are looking at open woodlands for hunting strategy. They hardly target bats anymore. They only target couscous. So we don't see this here, but that would be a really interesting thing if we see a translocation of animals. Whether that was accidental, the introduction in Western Britain, we don't know. The assumption is that it's not, that people were active agent in moving these kind of animal species to increase productivity of these islands. We don't see this here yet, but it's early stages, so it might be that this is going to be happening too. Yeah. Yes.
First a comment and then a question. Whereas I share your concerns about the migration model based in particular on Austronesian language spread. And I also think it's too early to be accepting genetic data in the way archaeologists have rushed to do. I understand that the model you're proposing is for island Southeast Asia, for this early movement of material and people. But were you also implying that this would be relevant for the Western Pacific? I mean, for Melanesia and
No.
only South Island?
No. No. So I'm not proposing that there's a Pleistocene occupation of islands anywhere south of the Solomons. Not at all.
Okay.
So one of the important, so for those of you who can't follow that argument, so there's a very strict boundary between the southern part of mainland Solomons and everything else. So we call that in Pacific research the boundary between near Oceania and remote Oceania. So the definition of near Oceania which includes all the islands west of this boundary, is that there's a Pleistocene occupation happening. So people are moving into the northern of Solomons about 30,000 years ago. So we have sites there dating to 30,000 years ago. But there's a strict biogeographic boundary again at the southern Solomons where the sea gaps are getting huge. So the sea gap between Vanuatu and Fiji is 800 nautical miles. So that's huge. That was a real biogeographic boundary. Pleistocene people did not cross into Vanuatu, New Caledonia, Fiji, and so on. Not at all. And but this is an interesting question. That's where it starts to get a little bit complicated, unfortunately, is because, yes, La Peter is the founding population in the Western Pacific. It is a Neolithic culture. It's about 3,000 years old. That model of a Neolithic culture colonizing the islands in the Western Pacific is being used to explain the spread of Neolithic groups in island Southeast Asia. And that's where the link is. And that's why, and this is why this is the Austronesian languages and the genetics comes in, because the idea is that this founding population, which the later representation is Lapita, starts in Taiwan, spreads through the eastern island Southeast Asia very quickly, doesn't really admix with anything there, but has this legacy of social interaction in island Southeast Asia, and then moves very quickly into the Western Pacific. The model works for the Western Pacific because all these islands, Vanuatu, New Caledonia, Fiji, and so on, Tonga, Samoa, they were uninhabited up to the late Holocene. The earliest colonization is Lapita, no argument about that. It is very different in island Southeast Asia.
Any more questions? Christian, I wanted to ask something,
Yeah,
if I may.
please.
I have about 10 questions, but I'll choose one. So, you presented in detail the two sites and how obsidian drops off. Is that a general trend?
So that's the interesting thing, is that is a trend which is only on Kisa at the moment. Well, yeah, yes and no. Like we don't have a similar archaeological record like you guys do here in Europe. There's not that many sites being excavated yet. Most of these sites are small. They are, like I said, they are 1 square meters. Just to understand the cultural sequence. So we are not talking about understanding we talk about site formation processes, but we are not really talking about sort of activity areas in a site and so on. We don't really analyze that because at the moment we just try to understand the cultural sequence. So the interesting thing about Kisa is that you do have this cut. So the later period, there's a real hiatus. We don't see this hiatus in other sites. So there we do have continuous records from the late Pleistocene into the Holocene. Aloha, the Trombone Lay site, for example, we do see continuation of obsidian use throughout the sequence, so that looks different. Whether this is associated with the small island problem, that's a different question. So it seems to be, and that would be my argument, is that you do have these interaction networks happening, but they don't guarantee a successful colonization. They are just a fallback thing for people. And yeah, if they aren't successful and they can't survive on these islands, that's why these networks are there. So they move. And then they come back with a new technology, with better productivity technology, and then survive on these islands. Not necessarily just because you have Pleistocene occupation on it, meaning that they are permanent. So, but the idea of you have these big islands like Sulawesi, like Borneo, like New Guinea, and we had this interesting debate in Leiden about it, is like whether people actually see these islands as islands. In the end, Australia is an island too. I mean, Eurasia is an island in the end. But it's like, do people perceive these huge land masses as islands, or do you actually talk about coastal adaptation? That's two different things. I think islands become more important when they're getting smaller, because then people are actually, they see that as an island, and you see different adaptation processes happening, different behavior happening there, and which includes abandonment.
Any last questions? Okay.
All right,
I think
thanks.
say a massive thank you, Christian.
You're welcome. Was it okay? Not too boring? I think people were falling asleep after a while. That's why I wanted to cut it short.
listen to
No
hear the
problem, no, no, no,
questions.
no.